Lesson 20.1, Task 4. Choose a linear model. All right, the Johnson family has taken a vacation to Niagara Falls by car. The table shows how the odometer reading on their car changes over time as they travel. All right, so in the left-hand side, you're going to see time in hours. That's your X, so 0 through 6. And then your odometer is how many miles is on your car. So this is in miles, and this is going to represent your Y value. So you can see at time 0, when they started their trip, their car had 25,500 miles on it. After 6 hours, they had 25,839 miles. So you can take that table, put it in your calculator, and draw a regression with that. All right, so it says find a function that models the data well, then use the function to predict the odometer reading after 8 hours. Make a scatter plot of the data and use regression to find a good model. Enter the data into a graphing calculator and make a scatter plot. The data points lie close to a line, which suggests a linear model. So if you look here, you can see the points, and it does look very close to a line. We have been looking at other points that look kind of curved, but this looks very much like a line, which suggests linear. All right, the coefficient of determination for a linear model, r squared, is about 0.9986. It's also very close to 1. All right, so anything close to 1 represents that this is a good model. So a good model is your linear function, which is y equals 55.179x plus 25,504. So this is my slope, and this is my y-intercept. So you can see here that the y-intercept falls on the y-axis, and then you do rise over run, rise over run, rise over run, and that determines, that would be your slope right here. Okay? All right, so it says predict the odometer reading after 8 hours. Well, 8 is time. Time is our x, so all we have to do is plug 8 in for x and solve. All right, so if we do that, we get y equals 25,945 miles. Now, does that make sense? Sure it does, because it should be slightly above this. So 8 hours and then 25,900 and something miles, that does make sense for your table of values as well. So it's always good to look at your data and look at the table and the graph and see, is it reasonable? Is this a reasonable number? Does it make sense looking at the other numbers in the table? And it does. All right, so it says use the regression to find a quadratic model for the data. Which model, the linear model or the quadratic model, more clearly indicates the approximate average rate of change in the odometer reading with respect to time for x between 0 and 6, and explain. And this would be the linear model because your slope, your rise over run, it's a constant slope, and it does indicate a linear average rate of change. So again, this is an average rate of change, comes from your slope, but this is a linear model. It's a good fit because it represents a line. All right, consider what happens to the linear and quadratic models as the time x increases beyond the values shown in the table. Which model do you think more accurately represents the situation for increasing greater values of x? Select the phrases to correctly complete the statements. All right, so as x increases beyond the values, so if we made our table of values extend beyond 6 hours, 7, 8, 9, 10 hours, what would happen with these two models? So the first one says the blank function would more accurately represent the situation. We know that the linear model is more accurate in this case. So it would more accurately represent the situation for increasing greater values of x. That just means if you increase the table of values or the points on the graph, the linear function is going to continue to look like it falls on that line. All right, the blank model predicts that the Johnson family will travel the same distance per hour. Okay, that's linear because your average rate of change is your slope, and that's changing the same distance each hour. The blank model predicts that the distance traveled by the Johnson family each hour will blank, which does not model what happens when driving. All right, so this must be talking about the quadratic model. So the quadratic model predicts that the distance traveled by the Johnson family each hour will decrease, which does not model what happens when driving for long periods of time. All right, so you're not going to decrease how much you drive each hour. You want to stay kind of constant. You know, if you get in a traffic jam or something like that, it may interrupt your speed, your average rate of speed, but for the most part, a linear function is going to represent this data well. All right, that's all for task 4. If you have any questions, let me know.